Okay, so part one, we're going to electrify everything. Part two, we need to generate as much renewable electricity as possible. Part three, we need to store it. So when the sun isn't shining, when the wind isn't blowing, or whatever other technologies we need to implement aren't coming through for us, we need to be able to take all of the energy that we're generating from when we can generate it, hold on to it for when we can't generate it. So that's the next piece of the puzzle. Part four, we need to do something that's called distributed generation, distributed storage. This is where we get into something that even people that are in the decarbonization industry don't fully understand. Our power grid was not built for this. Our power grid was built for dealing with one-way power flows back in the 40s, 50s, 60s. And the notion there is people will demand power at different levels, and there's central power that's dispatched, and that central power generates up or down in a way that meets that demand. So there's one dependent variable, there's one independent variable. Now what we have is a situation where we're saying, oh, we can't control how much power we're generating. The sun and the clouds do. The rotation of the earth decides to. The seasonal amount of sunlight that we get at a particular plot of land over the course of a month does. We get more power in summer, we get less power in winter. It's that simple. And when the wind is blowing, when the sun is shining, that's going to determine how much power we're able to generate. So that means now we need to find a way to get that power to where it needs to go to. At the same time, we have to push it over wires that were not built for this. Because here's the thing, if you look about the energy consumption of a typical home in California, for example, 1,000 square foot, one-story, tiny freestanding house, you're going to be looking at this much natural gas consumption for your heating, maybe this much electricity consumption. But if we're talking about shifting all of that natural gas over to electricity on top of your existing plug loads, well, then the problem is the wires that go into that house were only designed for this. The circuit panel was only built for this. In fact, the electrical transmission wires might be sized in a way that they're so small that they're going to heat up over the course of a day, even in winter, when all that electricity is being pushed over them. But if we start doubling, tripling the amount, I haven't even started talking about switching transportation over. So once we start adding EVs into the equation, then it goes to a whole other level. We can get into situations where those wires are going to start melting if we push them too hard. Now, forgive me, technical line engineers and folks, they're gonna say, well, we're gonna shut them off before we actually get to right. The point is it's gonna break. The point is the system wasn't built for this. The point is we've got a whole series of technical problems that we need to solve, and they're expensive problems that we need to solve.